This week we're gonna put all our tools and techniques in good use with problems about words. So we have this word list, words alpha text, whole bunch of words in there. So the words alpha, all of this with the 26 lowercase English letters, and opening the file acts as a sequence of lines, and the word list has one word for line, so we can just build up the list with the list comprehension. So now when you read the line break character is at the end of the line, so strip takes away the redundant white space. So we find out how many words we have in the word list. So we have 370,000. So most of these words I don't myself even recognize. So there is a whole bunch of course, technical terms from all the sciences and fields of human life. But then there is also a whole bunch of really short words that I've never heard of. So somebody might, for example, turn this into a vocabulary sampling game. So what can we do with this word list that is also guaranteed to be in sorted order, but of course wouldn't be too difficult to sort if it were not. So let's demonstrate the binary search. Remember, binary search, or bisection method as it's also called, is a way to quickly locate the position in a sorted sequence where a particular element would have to be in for the list to be in sorted order. And let's demonstrate the binary search. We can now solve it, use it to solve a problem. Find all the words with the given prefix. So here is a couple of prefixes that the word list is so big that there is words for all of these prefixes. So what can we do? When we're building up a result, we can start with an empty list, and the bisect left to the given sequence. So we search the individual prefix there as if the prefix were an actual word. So it may be or may not be, but the bisect left is gonna find us the position where is the first word that starts with this prefix, or if the prefix doesn't exist, then the next word in the dictionary. So this is handy that the lexicographic ordering, how it works, that all the words that start with the same prefix, they are consecutively in the word list, and furthermore, so then this would be the first one of all such words if they exist. So we ask, so where is the first position that the prefix can potentially occur, and then while we are still inside the word list, so this condition is necessary that when we're looking for the last possible prefix, that we don't run out of the sequence. Accessing a list sequence past the end is a crash. Accessing a string sequence simply gives you the empty list. So that's where those two sequences are a little bit different. So as long as we are still within the word sequence, and the current word starts with, notice the strings have a method because so starts with, of course, is a syntactic sugar for a bit of a slicing calculation, but since this is such a common thing, so might as well somebody implements it. So now we can just say word starts with something and everyone understands what is meant. So left as an exercise for the reader, write the slicing expression that produces the same result. So as long as the word starts with the prefix that we're looking for, append it to the result and move on to the next word in the sequence, eventually we either reach the end of the sequence or find a place where the next word starts with a different prefix. And recall this standard idiom. Given a list of strings, then turn them into a single string. So this whole thing is a method in the separator. So we wanna separate with the comma and a space, which seems reasonable. Some other languages, the method that does that also takes keyword arguments. You can give some kind of a starting marker and some kind of an ending marker to the end. But that, of course, we could easily do with the string concatenation. So words starting with these prefixes, we find this many words with AOR, this many words with Jim. I don't know what this Jim cracker, Jimmy, well that's a word, Jimmy with. Yeah, so these are all walks of life, so humanity is large and does a lot of things. All kinds of proper words here, proposition, propositio. Well, that's interesting. Some kind of a Latin root. So I'm not a linguist, so we can only wonder. Now here is the same problem, but in a different spirit. So how about finding all the words that end a certain way? So now we have sorted our word list so that they sorted with respect to the starting prefix. But why don't we use list comprehension to create a word list that consists all the reversed words? So notice the canonical Python way to reverse a string. So just slice through it all the way through with the negative step size. So we create the list of the reversed words and the list method sort. Notice the difference between sort and sorted. So sort, when you call it like this way, you don't need to, this doesn't even return anything, just to make it clear that this is modifying the sequence in place, not returning the sorted version. So then the sorted sequence decorator doesn't modify the original, but produces the lazy sequence of sorted original elements. So sort modifies in place, and then sorted creates a separate copy. So this is important. Remember when you are messing up your data and when you're not. And looking for some suffixes that I forgot where I made up this. So ending, so where the word itus, so first one, habitus, ambitus, cubitus, looks like we're not getting this in the sorted order. We should sort this again, because now the word list is sorted with respect to the suffix. So of course, according to the prefixes, it cannot be at the same time. So we could construct a list and sort it. Maybe I should edit that one to the next version. So looking for a suffix, and we're reversing the suffix because when you reverse a word, so then the suffix becomes a reversed prefix. Now the logic is exactly the same as searching for a prefix, or searching for all the prefixes in a sequence of strings is the same as searching for all the words with the given suffix with the reversed words. So the logic, as you can see, is otherwise exactly the same. So here I have some duplication. Whenever you duplicate copy pasting your own code, need to think maybe the thing that you're copy pasting is an important thing on its own and should be a separate function. A histogram, I think this is coming from the statistics. So in the word list we find the histogram of individual letters. There is that famous etäoinsurlu, so the frequencies of the letters in the English language. Notice that here we have a etäoin, it's not the etäoinsurlu, because when you have a word list as opposed to the natural language, in the natural language we know that all the words are not equally frequent, so some words weigh a lot more for the general frequency of the letters. But here in the dictionary, so all words weigh the same, and then the long words even weigh a lot more, so we get a very different letter distribution than we would get, for example, if we run through War and Peace and counted the histogram of the letter frequencies there.